Selamat sejahtera. Hello, I'm Aisha. Have you ever flown a kite? It can fly really high and soars in the wind. Today, we will learn about the science and engineering of flying kites. The objective of the lesson are to identify and know which forces make kites fly stably and relate them to the anatomy of the kite. In Malaysia, where I come from, every state has its own special kite. Malaysia has 14 states, and our kites called wow have special names given to them. Let's watch this video clip about Upin and Ipin, a popular Malaysian cartoon at a kite festival in their village.
RM2, RM2, layang-layang RM2.
Wah, banyaknya wah. Macam-macam warna. Atuk, kenapa wow tu semua lain-lain?
Memanglah. Wow pun ada banyak jenis. Yang tu, wow kucing. Tu, wow kapal.
Wah. Yang tu.
Yang tu pula, wow pemalas. Corak pun tak ada. Tak patut masuk langsung. Mereka kata aku malas. Tapi, yang ni, wow paling cantik sekali. Inilah wow kebanggaan Malaysia. Wow bulan. Meh tolong atuk. Pegang elok-elok.
Okey tu. Mana cepat?
Sedia.
1, 2, terbang! Wah, cantik wow kita. Pandai kita buat kan Ipin? Pandai.
Korang nak main? Nah.
Those were some of our wow. Wow kucing, wow kapal, wow merak and wow bulan. Did you see how they fly the kite? There is a lot of science and engineering involved in the making and flying kites. Anyway, we will discuss this in detail in the later segments. For now, we will look at the anatomy of the kite. Break into groups of 3 or 4 and discuss the following. What is a kite? Can you sketch and label the part as well? You can share your kite flying experiences if you have any. I will see you in a little while. Hello again. Did you manage to describe, sketch and label your kite? Watch the following clip carefully. You can compare your answers there.
Banyaknya bulu. Nak buat apa ni tu?
Nak buat wow.
Wow.
Iya, wow. Layang-layang besar tu.
Layang-layang besar. Nak buat tu. Tapi kita orang tak tahu tu.
Inilah budak-budak sekarang. Semua tak tahu. Ikut atuk buat.
Upin! Lama kita orang tunggu. Kata nak main.
Korang buat apa ni?
Tak ajak pun.
Kita orang nak buat layang-layang besar.
Kita orang nak juga.
Saya suka.
Sudah. Tak siap wow aku. Elok naik.
Apa nak yang ni?
Atuk, berapa mak ambil?
Ambil lah seorang dua.
Cepatlah tu. Macam mana ni? Cepat tu.
Macam ni. Kau ikat sini pula. Lepas tu potong ni, tampal. Dah siap.
Ajar betul-betul lah tu.
Sekali lagi.
Okey.
Mula-mula, potong benang. Lepas tu, ikat kat buluh ni.
Atuk, saya sudah siap. Tengok.
Cepat dia siap.
Mimi. Betul tak, Atuk?
Bagus, Meme. Macam tu lah.
Terima kasih.
Tolonglah aku. Kau kan dah siap.
Tak sama pun. Layang-layang besar ke kecil?
Layang kecil. Yang besar tu wow.
Macam tu.
Aku nak buat yang besar lah.
Ipin, mana layang kau?
Belum siap lagi.
Mael, kau punya? Ish, banyaknya. Nak buat apa ni?
Nak jual tu. Boleh buat duit.
Huh? Habislah buluh aku. Meme, bawa sini layang-layang tu. Biar Atuk ikatkan tali.
Nanti.
Oh, cantik. Korang semua tengok ya.
Baik.
Ikat betul-betul. Baru senang terbang. Faham? Macam ni.
Macam ni ya, Tok? Betul tak? Macam mana kamu ikat?
Macam tu tak boleh terbang.
Oh.
Meh, betul-betul kan?
There you are. We now know a little bit more about the parts of kite and its anatomy. I'm sure you can try to make your own kites, but bear in mind that what you have seen from the video earlier is an example of diamond-shaped single-line kites with 2-point bridles. A particular kite might have only one bridle line connected to the flying line, while other types of kites may have 2, 3, 4, or maybe even more pairs of bridle line, depending upon the size of the kite and what a particular type of kite is designed to do. For example, look at some of these examples. I wonder how to get kites up in the air and what keeps them flying. Do different types of kite have different flying capabilities? How does size and weight affect the ability of a kite to fly? All these questions and more comes to mind as we look up at the array of kites that fill a sky at a large festival. To answer some of these questions, let me demonstrate a simple experiment through the next activity. I will use 2 different densities of cardboard. See what happens to the cardboards when I switch on the fan. Now, you will do one simple experiment in your group. The experiment will look at the effect of weight and lift. I will see you after you are done. Hi, the experiment was to show you the effect of forces such as lift and weight acting on the cardboards. In the experiment, the cardboard stays in the air due to the force called lift. Your 2 hands holding on both left and right side of the top edge of the cardboards provide an opposite and equal force that prevents them from flying off. Also, you would have seen that the lighter piece rises slightly faster than the heavier piece. Why is it so?
This shows that it needs less lift.
How do these forces work on kites? There are also other forces acting on the kite. Let's watch Upin and Ipin again.
1, 2, terbang. Hello.
Cepat Fizi, cepat. Aku dah tak sabar ni. Sedia
Ish, asyik kau je dulu.
1, 2, yeay! Woohoo! Yeay, yeay, woohoo, yeay!
Seronoknya. Penatnya. Tak naik pun. Kau tak jadi ni, Meme punya terbang, Meme punya terbang. Tengok, tengok. Hebatlah Mimi.
Wah, hebat dong.
Jangan, jangan.
Ya, Mimi punya jatuh.
Hayya.
There are 4 forces acting on the kite, and they are the lift, weight, thrust, and drag. The lift is the force that stops a kite from falling down. Lifts, as a caused by streamline curvature, pushes the kite up into the air. Streamlines are a family of curves that are instantaneously tangent to the velocity vector of the flow. When streamlines are curved, the pressure drops.
As the pressure probe moves toward the upper surface.
It has to be that way because air, like any other things, moves in straight line, cannot curve unless acted on by forces. Since a kite at a positive angle of attack causes the streamlines to curve, the pressure must be dropping as it moves from far away toward the top surface. Therefore, the top surface is at a low pressure. The same idea applies to the bottom surface in the other way. The pressure must be rising as a kite moves from far away towards the bottom surface. The bottom surface is at a high pressure. The pressure difference between the bottom and the top gives rise to lift. As stated in Bernoulli's principle that when air speed increases, the air pressure decreases. Daniel Bernoulli was a scientist in the 18th century.
You can experience this phenomena when you put your hands outside the window of a moving car and position it at different angle. Take a look at this video. Discuss with your teacher and friends what just happened during the phenomena of lift.
Now let's learn about other type of force, which is weight, by watching the next video.
Jangan, jangan.
Ya, Mimi punya jatuh.
Hayya. Kata angin loh. Macam mana mau main?
As you can see in the video, the kite fell down. Why do you think this happened? The second force is the weight of the kite acting downwards. It is due to the pull of gravity on the kite. Gravity pulls everything towards the center of the earth, so kites in the air can get pulled down to ground level. That is why many kites are usually made from lightweight materials. The heavier kite requires a higher wind velocity to fly. Once you have a strong steady wind, it is not really hard for someone to fly any type and size of kite.
Well, thank you, Aisha. Hi, I'm Jeff. I will assist Aisha on the explanation about the forces. Now, let's extend our experiment. We will use different materials, some with tails, some without. We will also try different wind speed. How will these differences affect the movement of your strips? Discuss your observations with your group members and try to relate to kites. What type of material would you use to make your kite fly higher and why? Does more wind help? What is the effect of having a tail? Have fun, and Aisha will see you in a while.
experiment was to show you the effect of the wind speed and to show you a little bit about the effect of drag. Since we also used different materials, we saw that weight also has an effect on the lift. Did you see that a lighter material and a fast air speed make the miniature kite fly at a flatter pitch angle? The higher air speed created a bigger pressure difference, resulting in a bigger lift. Thus, the miniature kite fly at a flatter pitch angle, as how real kite fly higher outdoor. What about the tail? What is the effect of having a tail? We will discuss the answer next, but before that, let's watch this video.
Nak lawan aku ya. Tengok ni, tengok.
Nak kau?
Ih, tak boleh jadi ni. Harap kau boleh kalahkan aku.
Tinggi je layang-layang kau. Iseng, mana benang kau? Layang-layang kau tak pakai benang
Layang aku.
From the video, did you see how they pull on the string and the kites flow higher? This is due to thrust. Thrust is the force that moves the kite forward. Anyway, what is thrust? Thrust is the component of tension parallel to the wind, which is horizontal only when the wind is horizontal. Tension is the force that occurs as they pull on the string. The string provides the tension which gives us the thrust. Birds flap their wings to produce thrust and sometimes even to produce lift, while an aeroplane uses an engine to provide thrust. A kite doesn't ordinarily produce its own thrust. When we fly kites, we use a string to hold it and to prevent it from being blown away by the wind. The fourth and final force is drag. As the air flows over the surfaces of a kite, the wind gets held back a little bit by the roughness of the fabric and the sticks. Nevertheless, having a perfectly smooth kite does not guarantee zero drag, as there are many other factors that can cause drag, such as the shape of the kite. Now, we are getting to the tail. By having a tail, we can create an additional drag, and importantly, a drag that is located aft. This will allow us to make the kite point in the correct direction and gives a kite stability. If a kite has too little tail, it will not be stable and will move around a lot and might even start spinning around the axis of the string. If the kite has too much tail, the kite will be stable, but may be hard to keep flying because of the extra weight caused by the excess tail. The same forces act upon kites of any shape, even our wow. Although wow has no tail, but the curved rear part acts as a tail and the fringes at the sides adds more drag. Let's watch this video to see what I mean.
Wah, banyaknya wah. Macam-macam warna.
Wow kucing.
Wah. 1, 2, terbang.
So, to fly, a kite needs the lift, weight, thrust from the tension in the string and drag to be balanced.
Hi, it's me again. I will assist Aisha to recap what we have learned about kites. You need the forces to be in balance when the kite flies. all the forces reach equilibrium or balance when the kite rises to its maximum height. At this maximum height, the lift and drag forces exactly balance out the tension and weight forces. With no resulting force on the kite, it moves neither up nor down until the wind speed or the length of string changes. Kites have many uses: scientific, military, as well as for recreational purposes. The military uses kites in target practice. Kites were fitted with rudders and dragged from one side to another to simulate a moving object such as a running person. And for recreational activities, we have kite surfing and kiteboarding, as well as kite competitions for kites of various types and shapes. A major research and development project called Makani Power, based in California, is investigating the use of kites in harnessing high-altitude wind currents to generate electricity. How exciting! But we have come to the end of our lessons, and I hope you have enjoyed them. You saw how easy it was to make a simple kite, so I hope you will try and make your own kite. Go out, fly your kite, and enjoy the experience. If you want to know more about Malaysian Wow, have a look at this link below. Goodbye and have a great day.
The video is about the science of kite flying and the setting is in Malaysia. The video can be used as an extension of a physics lesson, especially after the student have learned about the forces. It will focus on some of the concepts such as weight, thrust, lift, and drag. Some principles such as Bernoulli's principle and Newton's law is now framed within the context of flying kites. With this video, students are encouraged to think about kite flying in terms of scientific concept of flight while discovering and enjoying the world of kite flying, which is shared throughout many parts of the world. As an added value, this video will also share some information about Malaysian kites, which are tailless. The Malaysian kite is called Wow, and there are many distinctive designs, and each Malaysian state has its own official wow. Malaysia has 14 states. You might want to draw their attention to the shapes of the typical kite and the wow. What features are the same and how they are different? The objective is to draw students' attention to the fact that kites are designed based on scientific principles related to theories of flight. The lessons provided are to be conducted in class, and students are to work on the questions given in the lesson in a small group. Students are to carry out 2 simple experiments to study how air flows on a kite. There are many types of kites, such as the diamond and delta kites, bow, cellular, and multi-line kites, figure kites like our wow, and soft kites. For more information, please refer to the website www.kite.org. If time permits, you want to take your students for kite flying activity outdoor. If not, just refer to the activities that we have suggested. If your students are not familiar with kites, you could use other analogies, such as paper airplane or paragliding, but you will not have to explain to your students the distinct differences of forces involved in every analogy you give. Thank you for viewing this video.